Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation, and we're going to use the power constant and sum rules. We're going to differentiate each function with respect to the given variable. So if I was given this function, h of s, and yes, these are my s's, is equal to the square root of 2 times the third root of s plus the square root of 2 times the fifth root of s. Okay? One thing to note that these two square roots of 2 up front are still constants. There's still these numbers there, right? It's a number in front of what's going on there, right? The cube root of s, the fifth root of s. So be careful with that. A lot of students try to derive those, and you can't. They're still constants. They still have all the rules of constants there. Well, what I'm going to do before I derive anything, I'm going to rewrite these instead of the cube root of s to be s to the 1/3 power, and the fifth root of s to be the s to the 1/5 power. And I like seeing fractions when I apply the power rule. So square root of 2, this is s to the 1/3 power plus square root of 2 times s to the 1/5 power. Okay. Well, now I can apply the power rule. So apply the power rule, you bring the fraction of the exponent down, and we subtract the exponent by 1. So we have h prime of s is equal to 1/3 times the square root of 2, s to the 1/3 power minus 1, plus, here, 1/5 comes down, 1/5 times square root of 2, and then it's s to the 1/5 power minus 1. Okay? Well, hopefully we're getting better at 1/3 minus 1, but if you need the note here, if I want to show the 1/3 third minus 1 is the same thing as 1/3 minus 3 over 3, which makes it easy to see negative 2/3 right there. The same thing here, that little note here, 1/5 minus 1 can be 1/5 minus 5/5, which is the same thing as negative 4/5. Okay? So let me simplify this up here. And in doing so, what I'm going to do is kind of combine everything. So we're not going to combine anything, but I'm sorry. Getting ahead of myself there. So 1/3 times square root of 2, and this is now s to the 1/3 minus 1, which is negative 2/3. 2/3 power, plus 1/5 times the square root of 2. That's s to the negative 4/5 power, which we found on the side. There. So now I don't like to have my exponents to be a negative number, so I make a positive and put them in the denominator, common technique. So we have h prime of s here is, and now I'm going to do this and combine them all together to, here's the combination part, to one big part. So we have the square root of 2 in the numerator over the 3, right, that 1/3. But the s now goes down to the denominator, and it's, instead of a negative 2/3 power, it's a positive 2/3 power. Okay? Then we have plus here, square root of 2 over the 5. And instead of, again, the s being the negative 4/5 power, it's the denominator, and it's going to be a positive 4/5 power. And there we have it. Our final answer here, which I forgot to put the little parenthesis around the s there, where h prime of s is equal to square root of 2 over 3 times s to the 2/3 power, plus the square root of 2 over 5 times s to the 4/5 power. So let's recap here. We're given our equation here. H of s is equal to the square root of 2 times the cube root of s plus square root of 2 times the fifth root of s. Well, I rewrote that instead of the cube root and fifth root to be 1/3 power and 1/5 power respectively. And so then I can apply the power rule. That's my personal preference in seeing it. Apply the power rule, the 1/3 comes down out front, multiplication, and we subtract the exponent by 1. Same thing here, the 1/5 came out up front, and we subtract the exponent by 1. When we simplified that, we have 1/3 times square root of 2 times s to the negative 2/3 power, plus 1/5 times square root of 2 times s to the negative 4/5 power. Again, I don't like to see exponents being negative, so we bring them down to the denominator to make them positive. And so we have our final answer here, in doing so, combining both parts together, or this together and that together. The h prime of s is equal to the square root of 2 over 3 times s to the 2/3 power, plus square root of 2 over 5 times s to the 4/5 power.